Alright friends, it's your boy Mr. Shaggy coming at you with another lesson. Today we're going to be looking at constructing the coordinate plane. And so when we're thinking about the word construction, it means how do we build the coordinate plane. So we're going to talk about what numbers do we need to count by, so what's the scale involved in the coordinate plane, is the data represented correctly? So that's what we're going at with this lesson. So we're going to be walking through sort of how to determine what we should count by or what our scale should be in this lesson, as well as understanding points, like points on the same line, like what we need to know about them. And so that's going to be what we're going to be looking at today. So the first thing says English winter, the following data were collected over one December afternoon in England. And so you have the data here: time, afternoon, hours, and temperature. Anytime I'm given a table, I want to make sure that things match up. So it tells you in the graph that your x-axis looks like it's time afternoon. So I'm going to write x here and y here. Kind of like an input-output table in that you have input-output, right? I like to think of it that way as well. So we're trying to match this data with one of these graphs over here and determine which axis would best support that data, right? So looking at this graph, I see that there are positive whole numbers and negative whole numbers. So I'm looking for a graph that includes both of those. So it says, which set of axes would you choose to represent these data? Explain your reasoning. Well, if you look at A, right, you can see that these are all positive numbers. So your negative numbers would not be represented on this graph. So A is wrong because there are no negative numbers. In B, you have negative numbers and positive numbers, right? So you have some negative and some positive. And you can see that the scale is, so this is 0, so they're counting by twos. So, right, anything between, like where they skip would be 1, right? So this is counting by twos, but also you could be counting by ones. If you place the 1 like right here, then you can see that you're counting by whole numbers, which is pretty good. C has negative numbers, but in this scale, right, that's 0, or the origin, you can see that's counting by 10. And so if you look at this, right, these numbers are less than 10. So thinking about that, right, if we're going to scale this properly in our coordinate plane, we don't want something that's too big, because then all the points kind of, you can't really identify their coordinates. And so that's what we're looking for here, is we're looking for the best graph. And so the best graph that represents this data would be B, because if I were to plot this data on B, right, you could individually define each point, whereas in C, because we're counting by 10, the numbers are far too apart, and you can't tell which point is which point, and it's not great for directions. So I would choose B because the scale used allows, the scale used includes all the data points. Right, so B, it includes the scale, allows me to plot all the data correctly, and everything fits nicely. So C would work, but the thing is that everything would be too clumped together and it would be hard to determine the difference between points. So that's what I want you to take away. Explain why the other two sets of data did not seem as appropriate as the one you chose. A only includes positive numbers. And C's scale is too large to fit the data on perfectly. Right? So that's why those other twos don't work. So that's the first activity, and we're really trying to get you to understand the best scale to use. So in the second thing that we're looking at today is called axis drawing decisions. And so you're going to be giving coordinates, and you're going to be asked to draw and label an appropriate pair of axes and plot the points. So for this activity, the goal that really is the scaling of the numbers to make sure that the numbers fit appropriately on your coordinate plane. And so if I'm looking at this first set, these are all whole numbers, excluding the fact that I have 1, 2, and a half. But if I were to look at these numbers, I could count by 1 and be perfectly fine. That's a good scale to use. You could visibly see each point. You could also, you also want to make sure that you include negatives. So I'm just going to draw, my coordinate plane somewhere in the middle, right? Kind of just like that. So draw my axes, and then of course where they intersect is 0. So if I want to label that like this is 0, that's great. Then I'm going to plot each point or scale it. So this is my x, this is my y. That needs to be labeled. And then I'm going to plot points. So I'm going to count by ones. So that would be -1, -2, -3, -4, -5. It's -1, -2, -3, -4, -5, -1, -2, -3, -4, -5. Now I'm going to plot these points. So I have my scale, so these would earn you points. Labeling, right? This is x, this is y. Showing me the scale, what you're counting by, right? The scale is what we're counting by, and then plotting the points. So it'd be like a 4-point sort of thing. So first, your axes, right? Your axes would have to be scaled properly. You'd have to label your point, and then you'd have to plot, right? So why did I don't know why, I just mirrored that. These are supposed to be positive. I don't know why, I had a brain fart there. So 1, 2 would be there. 3, -4. So 3, 1, 2, 3, 4. -5, -2, 1, 2, and 0 and 2 and a half. So 0, 1, 2, 2 and a half. Those are the points, right? And you can see that each point you can figure out based off the scale that's used. So there's no guessing work as to is that 7 or is that 1 or is that this or that. So the next thing is we're going to be looking at B, and in B, right, for this example, notice that you have 10, 30, 50. Well, a good number to count by here seems to be 10, because 10 goes into all these numbers, and this could be a halfway point, right? 5 is half of 10. So again, I'm going to draw my axes, and then I'm going to use a scale of 10. So I drew my axes, label my axes, scale my axes. So this is 10, that's -10, that's -10. This is +10, that's -10, right? So this would be 20, 30, 40, 50. -20, 30, 40, 50. -20, 30, 40, 50. 20, 30, 40, 50. So I've scaled, if you can look at that, I've scaled everything. I'm counting by 10. I want to be able to determine each point individually. When graphing, it makes it easier for me. So that's what I want in this example. So for this activity, right, we're going to plot the first thing. We have 50, 50, right? So 50 and 50 is there. 0, 0 is there. -10, -30 is here. And -35, so halfway, 40, -35, so about there, right? And so you can see that the whole thing is that when we scale something, right, we want to make sure that the points, each point can be identified individually. We don't want it to be a guessing game. We want it to be reasonable, and we want to make sure that it makes sense. So in the last scale that you're given today, you'll be given a fractional part, right? And so if I'm looking at this, right, I'm looking at this and I'm thinking, what could I possibly count by? Well, to me, it looks like I can count by 1/4 because I know that 2/4 is the same thing as 1/2. So I'm going to scale this by 1/4, right? So I'm going to draw my axis. That's X, that's Y. And then I'm going to scale. This would be 1/4, 2/4, 3/4, 1, 1 and 1/4, 1 and 2/4, 1 and 3/4. Right, so you get the idea, -1/4, -2/4, -3/4, -1, -1 and 1/4. Right, and then we have 1/4, 2/4, 3/4, 1 whole. And then we have -1/4, -2/4, -3/4, and -1. So you can determine that I've used my scale here, right? And so I want to make sure that each point that I have is represented individually, and that the scale makes sense or it has good reasoning. So my reasoning is I look for a number that all of them share, and then I try to count by that because it makes scaling so much easier for me. And know that I did not separate that perfectly, and that's okay. So in this, my first one is 1/4, 3/4. So 1/4, 3/4 is there. -5/4. Well, -5/4, that's a improper fraction. That's the same thing as -1 and 1/4, which is here. So I'm going to write that for you. Those are equivalent. And then that's a +1/2. That's the same thing as 2/4. So we have 1 there. Then we have -1 and 1/4. So again, and then -3/4, which would be here. Then we have 1/4 and then -1/2. So the whole point is that I want to be able to look at your graph and see that each point is represented individually based on the scale that you have used. So you really need to think about what scale you're using, because it's going to help you understand. The scale is going to help you plot the points to where they are reasonably located on the plane. And so now it says, discuss with the partner, how are the axes and labels of your 3 drawings different? Each drawing has a different scale. So that's something. So how are the axes and labels of your 3 drawings different? Each drawing has a different scale. You count it by something different, and that's the thing that we need to take away from here, is that you've counted that each one has a different scale, and that each point is able to be found individually. How did the coordinates affect the way that you drew the axes and labeled the numbers? Well, the coordinates help me determine what to count by. So the coordinates determined what I should count by, aka the scale I used. Right? So taking this, right, we need to understand that the scale used is determined by the coordinates. So you look at the coordinates, what do they all have in common? Can you find something they all have in common and use that to help you draw the scale? Right? And so the last thing that we're going to be looking at today is we're going to be looking at a maze. So it says, here is a maze on a coordinate plane. The black point in the center is 0, 0. So I know that this is 0 here, that direction, and it's also 0 that direction. Notice that this coordinate plane is a little wonky compared to what we've been looking at before, right? So that's 0 and that's 0. The black point in the center is 0, 0. The side of each square grid is 2 units long. Now, here's where the tricky part is. Like, treat this, right? Treat this as your x-axis. So think about this as x, and think about this side as your y. Now, I'm going to walk you through this. So this is 0, right? So to the right of 0, we know is 2, and to the left of 0, we know is -2, right? Because each one of these squares, they told us the scale is 2 units long. Now, looking at this 0, Below it would be -2, and above it would be +2, right? And so we need to understand that. So I'm going to go ahead and label the rest of this: 2, 4, 6, 8, 10, 12. And then -4, -6, -8, -10, -12. This is -4, -6, -8, -10, -12, -14, 4, 6, 8, 10, 12, 14, right? And so now I'm going to use that information to help me, right, help me determine these questions. So enter the above maze at the location marked with the green line segment. So we're entering there. Draw segments to show your way through and out of the maze. Label each turning point with a letter, then list all the letters and write their coordinates. So let's just start this with A. Well, A's location, it looks like it is halfway between -10 and -12 down here. So if it's between those two numbers, then I would assume that I'm going to start with A. A is -11, and then it's between these two, 9. And then it moves over here, and we can see that that's between, this is where it gets confusing, right? It's between -6 and -8. So it's halfway. So I would say that your next point is B, and that's -7, and then it's on the same line, 9, right? -7, 9. It just moved. So -7, 9, and then your next point is still on -7 because you're on a vertical, and then -7, and then it's moved down between 4 and 6, which is 5, because that's halfway between, so we'll call that C. So it says we need to determine our way out of the maze, right? And so to get out of the maze, we need to get out this way, right? So we need to really think about where it is that we're going. So I could go this way, right? I'd stop there, and then I could enter this way, go this way, go this way, go this way. That seems like a long way to go. Or I could go this way, down, this way, down, this way, up. That looks like the best path. So I'm going to go over to where I can turn again. So I'm going to go there, and I'm going to connect those points, right? And I'm going to call this D, right? So D is on, so D, I went that direction, so D would be negative, so D would be actually a positive number now, so it looks like, it looks like it's on 1, so 1 comma, and I'm still on 5, because it's the same horizontal line I was on before, and then I'm going to go down, right, to this, and then I have to turn again. So this one I'm still on 1, so I'm going to label this E, 1 comma, now I'm on, that looks like it's on 3. Then I'm going to go over here, draw my line, and then I'm going to say that that is 7, so this is point F, 7 comma, and it's the same thing, so 3, horizontal line, then I'm going to go down until there's an opening, so down. So my X has not changed, so that's going to be G, and that's going to be 7 comma, now we're in negative numbers with Y, 7 comma -9. And then I'm going to go over here, and then now I'm, it looks like I'm past, so now I'm at -1, so H, -1 comma -9, and then I go up, I, -1, -5, and then I go over, this is going to be J, that is -5, -5, and then my last point to get out would be there, right? And so K would be -5, -5, -14. That would get me out, right? So what I just did was I did a maze activity, right? But in this activity, what I'm doing is that each time I turn, so I went, this is a horizontal line, right? I went between those 2 points, then I had to make a choice between going forward or going. So anytime there was a directional change, I was deciding which way to go. Now I found my path before, the end, and then I plotted my points. So the thing is that throughout this whole activity, I knew, right, based off of the type of line, so if I have a horizontal line, such as this, right, if I have a horizontal line, the y value is not changing, just the x value, because I'm only sliding, right, left or right in this direction. If I have a vertical line, right, the only thing that, if I have a vertical line like this, then my x is staying the same, but my y value is changing because I'm moving up or down, right? And in this case, it's down. So that's the big goal of this activity, is to really understand how to piece those things together. So when you make a vertical move between 2 points, you are really just looking at the difference between two numbers, right? Because one number stays the same. And so that's really what we're trying to get at. So the second part of this says, choose any 2 turning points that share the same line segment. What is the same about their coordinates? Explain why they share that feature. So if I were to choose any of these coordinates, right, what I just talked about with you was, I talked about the fact that if 2 numbers are on, so this one and this one, so let's say that I'm going to share these 2 things, or let's just use the last one. So let's use J, which is -5, -5, and K, which is -5, -14. Well, if you're looking at both of those, I notice that the x coordinate is the same, right? Because it's a vertical line, the x has not moved, but the y has changed. And the y changed from -5 to -14, and that's a distance. And when we talk about distance, we know that we're talking about the absolute value, right? So the distance between those 2 points would be 14, like the absolute value of -14, minus the absolute value of -5. In this situation, that's 14 minus 5. And we know that to be 9 units, right? So that has a 9-unit difference. So when looking at these points, both of these points share the same x coordinate because they are on a vertical line. Right, so this tells us, right, this is the end sort of what we're getting at here. And I know that it took me quite some time to work through this, but the thing about, this maze is that we really need to understand that points that share a coordinate, are on the same line, whether that be vertical or horizontal. We just have to be able to determine if it's vertical or horizontal based off of the coordinate that they share. And then today's exit ticket. So Sterling drew this set of axes and plotted the points. A, 1, 2, B, -3, -5, C, 5, 7, D, -4, -3, and E, -4, 6 on them. Identify as many mistakes as you notice in Sterling's graph. Well, first I'm going to start by identifying x and y values, right? So that's labeled properly. A, 1, 2, so I agree with that. He plotted that correctly. B, -3, -5. B is plotted correctly. C, 5, 7. Well, here's our first mistake. C is off by 1, right? Because that's supposed to be 5, 7. He plotted 5, 8. D, -4, -3. D is also incorrect. D is off by 1 unit. And then E, -4, 6. E is plotted correctly. So that tells me, right, that tells me that. I'd also say that the scaling, maybe the scaling is off, but I would notice that those two things, you should be able to tell me that they're plotted incorrectly. All right, and this is Mr. Shaggy signing off. I'll see you next time.